ಸರ್ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು ಸರ್. Good evening, one and all. My name is Kotesh Karji. I am now I am explaining about this PPT of solar-based refrigeration. Now, abstract. It means the total brief introduction of the our project. Uh, Solar energy is proved to be an ideal source for low temperature heating application. Three known approaches that use solar energy to provide refrigeration at temperature below 0 degree includes those are photovoltaic operator and refrigeration and solar mechanical and absorption refrigeration. These are the three types which are used in the solar refrigeration. Both photovoltaic operated and solar mechanical cycles rely on vapor compression refrigeration, and whereas absorption refrigeration uses thermal energy at the primary input to the cycles. These are the ty- these are the what the PV operated system. Next, among these three approaches, the photovoltaic system is the most viable and appropriate means for the small capacity portable systems located in areas not near conventional energy sources. These are the three approaches to in which the solar operated refrigerator works. Now the introduction part will be explained by our friend Nityanand. Nityanand, go ahead. Nityanand, Mardesh, hello, go ahead. Suraj, wait, I will tell the working. Okay, working of the solar refrigeration system. It The first one is photovoltaic operated refrigeration cycle. That means the refrigeration cycle is worked by the using of the photovoltaic cells. That means the solar panel. First one, the photovoltaic involve the direct conversion of solar radiation to direct current electricity using semiconducting materials. That means whatever the solar radius, it is absorbed by the solar panel, and this solar panel convert the uh, solar radius into the electricity. Next, in concept, the operation of PV powered solar refrigeration cycle is simple, because the solar refrigeration PV is very simple. The photovoltaic, it means the light emitting diode. That means when the light is impacts on the solar panel, it creates the electrons. These electrons create the electricity. By this application, we can create the power. This is stored in the batteries. Next, vapor compression cycle with power input from the photovoltaic cells. Vapor compression cycle means the compression of the vapors, and done by using this concept we are done the refrigeration system. Next, DC electric power output from PV runs the compressor of a conventional cycle. That means the whatever the electricity produced by the solar panel, this is give to the compressor. It is connected by the battery source. By the virtue of the battery source, we can run the compressor, and then we perform the working of the refrigeration system. This is the what the layout of the, this is clearly shows the layout of the refrigeration system, solar refrigeration system. Initially the sun radiuses fall on the PV module, that means solar panel. By the virtue of this, the panel converts the solar radius into the electricity. Because it is in AC in power, we use the DC current. That means we use the controller to convert the AC into DC. After this, we give this power to the compressor. Via this, we can runs the motor to compress the what we call refrigerant to run the refrigeration system. The right side of the four components shows the refrigeration system. That means these are condenser, expansive wall, refrigeration chamber, evaporator, circulation, and refrigerate. That means in evaporator we put the specimen which temperature is to be low. When the refrigerant go through the coils, it absorbs the heat from the specimen, and reduces the temperature of the specimen. By absorbing the heat of the specimen, the refrigerant evaporates, and it is goes through the compressor. In compressor, the the refrigerant which is in a vapor form, it is compresses, and the pressure is rises via condenser. In condenser, the temperature of the refrigerant, it is goes to the atmosphere. And after that, in order to reduce the pressure of the refrigerant, we flows through the expansion valve. After this, the cycle repeats, and the specimen get into the low temperature. This is the what the complete working of the solar refrigeration system. That is the next. Solar photovoltaic panels produce DC electric power that can be used to operate a DC motor, which is coupled to the compressor of a compression refrigeration system. The major consideration in designing a photovoltaic refrigeration cycle involves the appropriately matching the electrical characteristics of motor driving the compressor with the available current and the voltage being produced by a PV array. PV model will operate over a wide range of conditions that are rarely as favorable as the rating condition. In addition, the power produced by a photovoltaic array means the number of PV cells arranged in columns and rows, is as variable as the solar resource from which it is derived. Solar mechanical system. This is explained by the our one of the friend Nityanand. Nityanand, go ahead. Okay, this is the solar mechanical refrigerator system. The layout of this, in which we can observe the solar collector, storage tank, and the heat exchanger, expander, and condenser. The total, what we call solar refrigeration, is layout in this form. And after this, this is the working of the out this solar collector, solar tank, and all this working is given this in this temperature. The Rankine cycle efficiency estimated for a high temperature organic fluid, assuming that saturated vapor is provided to a 70% efficient expander and condensation occurs at 35 percentage, that means 90 degree Fahrenheit. The overall efficiency of solar mechanical refrigeration defined as the ratio of mechanical energy produced by the incident solar radiation to the product of efficiency of the solar collector and the power cycle. Now this is the in rechargeable. There are three types. The third type is absorption refrigeration system, in which the whatever the what we call refrigerant which uses ammonium hydroxide, that means NH4OH. Absorption refrigeration is the least initiative of the solar refrigeration alternative. Unlike the photovoltaic and the solar mechanical refrigeration options, the absorption refrigeration system is considered a heat-driven system that requires minimal mechanical power of a compression process. It replaces the energy-intensive compression in a vapor compression system with a heated activated thermal compression system. Ammonium is the working fluid, that means the refrigerant. Minimal mechanical power input pump instead of the compressor. We need the pump. Why? Because the what after the NH4OH which is in the liquid form, in order to raise the pressure, we use the pump as the media. Absorption into water solution allows it to pumped. Okay, dissolved in generator. Rectifier required a separate out water. This is what the using of the observe refrigeration system. Next, this is heat into generate provided by a solar collector. The pressurization is achieved by dissolving the refrigerant into absorbent in the observer section. Subsequently, the solar is pumped to a high pressure with an ordinary liquid pump. This system greatly increases complexity. Advantages is explained by our friend Basraj. Basraj, go ahead. Martesh, go ahead. Maruti Naik. Oh, Martesh, go ahead. Okay, thank you. Conclusion: the whatever the after this our project is made, we come to a conclusion that is COP, coefficient of performance for solar refrigeration system, is low. Better matrix size, cost, complexity of solar refrigeration system requires more size. Bulkiness, low operating costs do not outweigh high initial investment. Advantage is that they don't rely on power grid. That means it does not require any external power system from the additional transformer or the other because we already use this from the solar system. This is what the conclusion. These are the reference. Okay, sir. Thank you, sir.